All right, so coming back in where the other video ended to kind of finish out this problem, we had been looking at this problem, and we had already determined that the b value was going to be pi over 2, that the a was going to be 3 from the amplitude, that the midline was at -4, so our d is going to be -4, and I was just getting ready to discuss the phase shift. So again, the phase shift, in taking a look at that, the phase shift I made for this problem, just so that we could practice it, having it be a phase shift to the left, I made the beginning of the period to be -4. And so in taking a look at that, that means my phase shift is -4. So immediately, once we have that, that tells us that C is going to be -4. So now let's put that all together and write down our equation for this. So this would be f of x equals my amplitude, which is 3. This is a cosine function. My b value was pi over 2, parentheses. Then our x, and this is -4, so remember, x minus -4 would become x plus 4. And then we close our parentheses, and then we have our -4 for our d. Now, just to kind of show you the kind of relationship with this phase shift, that if you actually pick a different beginning of the period, what if I decide that the phase shift is 0? And so if the phase shift is equal to 0, notice that the only thing that's going to change is that the equation is going to become 3 cosine pi over 2x minus 4. And you can test that out on Desmos, and you can take a look at that, and you'll see that it's exactly the same graph. And then also, kind of as another one, you could have picked that the phase shift was over here at this value, which is 4, so we could make the phase shift 4. So this would equal 3 cosine pi over 2 x minus 4 would also graph exactly the same thing. That because of the repeating nature, there are actually infinitely many phase shifts that we could pick in order to do that problem. All right, I'm going to leave this one for you to try on your own. So that'll give you 2 different ones that you're going to be practicing. Now what I want to do in this last part of this video is take a look at working the other way. In all the previous examples, we worked from the graph to the equation. Now we're going to work from the equation to a graph. So first thing, we're going to record our important characteristics from the equation. Sometimes I might rewrite this so it's in the transformation form. So kind of to put it in the terms where we have a sine, and then we have our b, x minus c plus d. So when we're looking at this equation, we're lining it up. We're going to say that our a is equal to 1. So that tells me that my amplitude is going to be 1. My period, because b is equal to 1, okay, so it's the same. I'm kind of bringing in the parts of the equation that are related to that. Since b is equal to 1, and remember that when we were looking at b was 2 pi divided by the period, so the period is 2 pi divided by b. And so that would end up with a period of 2 pi, because we haven't really changed it. There's no stretch or shrink. My phase shift, my c, is going to be 0 because there's nothing added in on the inside. All right, so phase shift is 0 because c is 0. And so the only thing that's here that's really important in terms of transformations is this is the only transformation that's there. And what that tells us is that d is -2, so our midline is y equals -2. Now, everything else about the sine graph is exactly the same. There's no vertical flips, there's no horizontal flips. The pattern is still going to be, because it's a sine graph, so you might want to make a note that the parent is the sine graph, so it's inflection, max, inflection, min, inflection. Right? When we go to graph this, we add our axes in, so I'm going to go ahead and add this in. When we look down, I'm going to go down below, because when I look at this, I need to make sure that I go down to my midline, and my midline is down here at -2. A lot of times you'll see me kind of dot in a midline just so I can see that as we're going. Now, in terms of our 5 key x-axis points, there was no phase shift and our period is still 2 pi. So on the x-axis, we're going to keep the quadrantals as our 5 key points. And then we're simply going to start in the beginning of our period. Let's set that, the beginning, because there was no phase shift. It's going to begin here at 0. It's going to end here at 2 pi. So when I go to plot my points, remember that we have to start on an inflection point. So inflection, our max is at the pi over 2, but it's going to go up 1, then inflection, then down 1, and then inflection. And so that kind of filling this in, -1, -2, -3. And that would give us 1 period of that. So our key ideas here are to identify where the period begins and the 5 key points, to determine your midline and your amplitude, and to also kind of sketch it out, using the correct pattern based on the parent graph. All right, let's look at another example. Now, obviously, this one's a little bit harder. There's a lot more going on. The first thing I'm going to do is I'm going to rewrite it in that transformation form. 2 sine, and I'm going to start by factoring out the 2/3. Now, to give you a little bit of help on that, we're going to do this over on the side. When I factor out the 2/3, what you're really doing is you are dividing by 2/3. Dividing by 2/3 is equivalent to multiplying by the reciprocal here. So I factor out the 2/3. To factor out the 2/3, you divide by 2/3. And then when you factor and you divide by a fraction, you can flip and multiply. So that's equivalent to that. So if I distribute that through, that's going to give me x minus 3 pi over 12, which is going to simplify to pi over 4. So what goes in the parentheses here is going to be x minus pi over 4. Once I write the equation in its transformation form, then I can go through and get the important values. Your A is 2. Your B is 2/3. Your C is pi over 4. And even though I don't have it listed here, our D in this case, I'll just put it right here, is equal to 0. So there's no midline shift as we do it. Now, I write down the important characteristics. So A is 2. Again, my period, what I'm going to do is, remember, B is equal to 2 pi divided by the period. So the period is 2 pi divided by B. We're going to multiply by the reciprocal, 3/2. So this ends up with 3 pi is going to be my period. And my phase shift is pi over 4. Now, what this does for us, that we're going to have to do a little bit more work for this problem. When I go to set it up, all right, so I'm going to go ahead and I'm going to put my axes in. My midline is on the y-axis because my midline is y equal to 0, so I don't have to worry about that. It's going to be the x-axis. I know that I need to go 2 above and 2 below, so I'm going to mark those here, -1, -2. We also know that this is a sine graph, so we're going to remember that our sine is going to be inflection, max, inflection, min, inflection. So we know we're ready to start, but now what we have to worry about here, and what makes this a more challenging problem, is that we need to determine the beginning of the period from the phase shift. So the 5 key points, one, we're going to do this pi over 4. So initially I'm going to put that pi over 4 there, and I'm going to make a note that that's the beginning of the period. Now the end of the period, remember, is going to be 3 pi away. Now that's kind of, important to think about that here. So pi over 4, now I'm going to kind of put some tick marks out here, because this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This would be kind of where pi is. Now that section right there kind of gives you, if we continue it out, here would be 2 pi, here would be 3 pi. And now remember, I need to go exactly 3 pi away from pi over 4. So I don't want to, if I was going 0 to 3 pi, that would be good. But I'm going to go one more tick mark past that because that's going to be exactly 3 pi away. Now, if I didn't know how to get that, remember that to get to the end of the period, if I take the beginning of the period and I add the period to it, I would get the end of the period. So if I start at pi over 4 and I add 3 pi to it, I would get 3 pi plus pi over 4, which is going to equal, let's do common denominators. It would be 12 pi over 4 plus pi over 4, which is 13 pi over 4. So that is going to be one of the key points. So let's change colors here for these key points and kind of highlight them. Now, in terms of exactly in the halfway point, and you know, it's one of those things that you just kind of have to do a little bit of side arithmetic as you're working on this. The 5 key points, remember they are equally spaced apart. So I could look at this and go and count by, I had gone up by pi over 4. And so I could count that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these pi over 4 tick marks in between pi over 4 and 13 pi over 4. Now, halfway would be, so half of the 12 pi over 4, trying to figure out where the middle of that's going to be, is that instead of going up 12 tick marks, I need to go up 6 of these pi over 4 tick marks. So here's 1, 2, 3, 4, 5, 6. And so I would be at that point. Now, what would be the value for that, this key point? So this is pi over 4, 2, 3, 4, 5, 6. This would be 7 pi over 4, counting up. And then 8 pi over 4, 9, 10, 11, 12, 13 pi over 4. So you can kind of see how that's leveling out. Now, halfway in between, let's count our tick marks here. There's 1, 2, 3, 4, 5. 5 tick marks in between, or 6, you went over 6 pi over 4 there. So I need to go over 1, 2, 3. Exactly in the middle would be pi. So that's going to be an important point. My 7 pi over 4, and then 1, 2, 3 here. 7 plus 3 is 10 pi over 4, or 5 pi over 2, and then 13 pi over 4. So really kind of the hardest part of this is going to be getting the 5 key points out on the graph. But remember, you can kind of just work your way through it, kind of lay it out in nice little tick marks. I would have a tendency to do it by common denominators. Notice that I went up by pi over 4 each time because I knew that I was beginning my phase shift at pi over 4. If I began at pi over 6, I might do tick marks every pi over 6 while I'm figuring out what's going on with this. All right, so once we get that down, then from here it's pretty straightforward. We can go ahead and fill in the graph. At the beginning of the period, we want to be in an inflection. At the quarter point, we want to be at a max, and then a min, or inflection, then a min, and then an inflection. And so that gives us one period of the graph. If I were to ask you like what the max point is, you should be able to tell me that it's pi 2. And that the min point is going to be 5 pi over 2 and negative 2. All right, so using that example, I'm going to let you guys come in and do the last 2 problems on your own, and we will discuss. So try and try this one down here as well. And that will finish up our videos for this topic. We'll come back in with some extra practice on Wednesday as well. Thank you.